Hi everyone, myself Dr. N. Pothanna, Associate Professor of Mathematics, VNR Vignan JYOTHI Institute of Engineering and Technology, Hyderabad. This class I am going to explain about evaluation of the integrals. So suppose I want to evaluate the integrals which are in the type of, for example, to evaluate the integration of sin square x into dx, or to evaluate the integration of cos square x into dx, then what basic formulas we required here, that we should know here. Then for example, to evaluate the integration of the type sin square 2x dx and integration of cos square 2x dx, then what type of the basic formulas in trigonometry we required, that we should know here. So actually all these evaluation of the single integrals are very much useful in the engineering mathematical concepts, like in vector integral calculus. These type of basic integrals are arising here. So in the evaluation of work done by the force, or in the evaluation of circulation, or in the evaluation of surface integrals, volume integrals. So these type of basic integrals are arises. Let us see how to evaluate the integration of sin x dx and integration of cos square x dx. If time permits, I can also explain about evaluation of the sin square 2x dx and cos square 2x dx. So we know that the basic formula of this sin square theta, or this 2 sin square theta. So the formula of sin square theta or 2 sin square theta we know in terms of the multiple angles. So that is it is 1 minus cos 2 theta here, or we can also write this as sin square theta is equal to 1 minus cos 2 theta divided by 2. Suppose I want the sin square x. If I want sin square x, just replace theta as x here. So this we can write as 1 minus cos 2x by 2. To evaluate the integral, so which is in the form, so integration of sin square x dx. Just now we have seen that. So we can write sin square x as 1 minus, it is cos 2x divided by 2 in terms of multiple angle. I am converting the sin square x because we don't know the integration of sin square x dx directly. So we have the formula of integration of sin x dx, cos x dx, like that. So to evaluate the sin square x, we need to convert the sin square x in terms of the multiple angles that just now we have seen. That is, we can write that as 1 minus cos 2x by 2. So you can write 1 by 2 as outside from this. So then take one flower bracket. It is integration of 1 minus cos 2x dx. We can write like this, close this flower bracket, and this is equal to 1 by 2 into, it is, now you can separate this two integrals. So you can write this as 1 into dx minus integration of cos 2x into dx. Like this you can write separate two integrals. So that is also equal to 1 by 2 into, so as we know that integration of this constant is x here, integration of 1 dx x we can write, and minus, so we also know that integration of cos 2x is, it is sin 2x, sin 2x divided by 2. So again we have to differentiate this 2x, then in the denominator we have to write. So because we know that, so integration of since integration of cos x dx is, integration of cos x dx is, it is sin x, and also we know that integration of sin x dx is, it is minus cos x. Using these two basic formulas, so these two basic formulas actually very important. So applying this formula, integration of this cos x dx, so I can write this as integration of this cos 2x dx as minus sin 2x, then 2x, this constant extra is there. So again we have to differentiate that, and we have to write in the denominator. So now finally we got integration of, therefore integration of, it is sin square x dx We got this as 1 by 2 x minus sine 2x by 2. So as we know that the integrals are of two types, one is definite integral and another one is the indefinite integral. So this type of integrals we call as the indefinite integrals. Whenever the limits are given, we can say that, so these are the definite integrals. Okay, so let us calculate the same integral here. Suppose we have given, so x is equal to some 0 to pi by 2 sine square x dx. To evaluate this, what we will do is, so as usual, we can evaluate this without limits, integration of sine square x dx we can evaluate. Then whenever the limits are given, so we have to substitute both these limits by taking upper limit minus of the lower limit substitution. So take one more bracket here. So x is equal to here 0 to pi by 2 are the limits. So now coming to the evaluation of this, we have to substitute the upper limit minus of the lower limit here. So this is equal to 1 by 2, anyway it is a constant, you can write outside. Then so at upper limit, so x equal to pi by 2, you can substitute in this. This becomes pi by 2 minus it is sine of 2 into pi by 2 divided by 2. Upper limit minus of the lower limit we have to substitute. At 0, x equal to 0, anyway this vanishes, this becomes 0, and also we know that sine 0 is 0, so therefore minus of 0 will get. Okay, so finally, so if you cancel out this 2 sine pi you will get in this first substitution at upper limit, so this 2 gets cancelled, so again you will get this as sine pi. So as we know that sine n pi is 0 whenever n is the integer, so therefore finally, so we will get this as pi by 4. So this is equal to, so 1 by 2 into pi by 2, that is pi by 4. So because this sine pi is 0. So like this we evaluate the indefinite integral and definite integrals of sine square x. So not only this, so many problems we can also see the evaluation of the integrals like cos square x dx also. So to evaluate this, so we know that the formula of cos square theta or 2 cos square theta in multiple angles. So you can write this as 1 plus it is cos 2 theta. So if it is cos square theta, we can write this as 1 plus cos 2 theta by 2. So you can also rewrite this as cos square theta is equal to 1 plus cos 2 theta divided by 2. So since the integrand is given in terms of x, so if you use theta as x, so therefore you can write cos square x as 1 plus cos 2x divided by 2. So let us use this in the given integral. So therefore to evaluate this integral cos square x into dx, so we can use this formula in this integrand. This can be rewritten as 1 plus cos 2x by 2 into dx. So let us separate this. 1 by 2 is a constant, we can write outside, take on flower bracket. Then you can also write this as separately 1 into dx plus, so it is the integration of cos 2x into dx. So now this is equal to 1 by 2. So just now you have seen that integration of 1 into dx is x. Then integration of cos 2x is sin 2x. So again this 2x we have to differentiate, and so differentiation of that is 2, we have to write in the denominator. So in this way you can evaluate, so this integration of cos square x into dx. So this we call as an indefinite integral. So coming to the evaluation of the definite integral, so here we got cos square x into dx as some 1 by 2 into x plus it is some cos 2x, no? So we got this as some sin 2x divided by 2, sin 2x divided by 2 here. So the same problem, so if they give it is for the definite integral, suppose we have given the limit says x is equal to some 0 to pi by 2. So as usual we have to evaluate integration of cos square x dx. So then we have to substitute the limits here. We have to substitute the limits between x is equal to 0 to pi by 2. So now this is equal to 1 by 2. So take one bracket, then at upper limit this becomes pi by 2. That means let us use x equal to pi by 2 in this expression. So sine 2 into pi by 2 divided by 2. So at upper limit, so take x is equal to pi by 2, then minus of lower limit, that is 0 plus it is sine of 2 into 0, that is 0 divided by 2. Anyway, so this complete value becomes 0. Then coming to the this first two terms, so this is as it is pi by 2 plus, so sine of, if you cancel out this 2 and 2, this becomes sine pi divided by 2. So this is equal to 1 by 2 into pi by 2. So sine pi we know that it is 0, 0 by 2 will get. So this is equal to pi by 4 will get. So because we know that sine n pi is always 0 whenever n is an integer. Like that, cos n pi, for example, if you get in any one of the problem, if you get cos n pi, cos 2 pi or cos 3 pi, you can use that as minus 1 to the power of n. Whenever n is integer, so you can use, so this cos n pi is minus 1 to the power of n here. So like this, so you can evaluate the integration, single integration of the trigonometric functions, these sine square x, cos square x, both the definite and indefinite integral. So in this way you can calculate here. So because why I am explaining these separately, these two integrals means, so not only in the evaluation of integrals separately here, so many engineering concepts, many engineering mathematics concepts, so these standard formulas like integration of sine square x or integration of cos square x are arising. So if you are perfect in the evaluation of this integration of sine square x and cos square x, so if any other concepts, this type of integrals arises, you can easily evaluate here. So not only the integration of sine square x and cos square x, suppose we have given the, so going to this third example, suppose we have given, so in the evaluation of the integration of sine square 2x dx, they ask to evaluate this one. So because we know the standard formula of this sine square theta, so that is, it is 1 minus cos 2 theta by 2. So using this, so if theta is there, so that becomes, it is twice multiple in terms of multiple angle, will write the formula 1 minus cos 2 theta. For example, if we have sine square 2 theta is there, so this 2 theta becomes double, that is 1 minus cos 4 theta divided by 2 we can write. So here he has given that, so sine square 2x, no. So if you use theta as x, you can write sine square 2x as 1 minus cos 4x by 2. So let us use this one in the given integral. So therefore integration of sine square 2x dx. So we can write this as integration of 1 minus cos 4x divided by 2 into dx. Why I am converting the sine square 2x in terms of that multiple angle means, so directly we don't have the formula of sine square 2x dx. So I am using the conversions here. So using that conversion in terms of the multiple angles, so I am converting this integral. Then after that, once this integrand is converted in terms of some known formulas, known and standard formulas, you can easily evaluate this given integral. So 1 by 2 is a constant, you can write outside, take one flower bracket, then separately evaluate this integration of 1 into dx, then minus integration of it is cos 4x into dx. So like this. So now we know that integration of 1 into dx is, it is x, minus integration of cos x dx is, so it is minus sin x, and or like that you can write. Okay, already we know that integration of cos x dx is, so it is the sin x, integration of cos x dx is sin x, using that formula. So in place of cos x we are having cos 4x, so therefore you can write this as sin 4x. So in place of x we are having 4x, therefore you have to differentiate that, and you have to differentiate that 4x, the differentiation of 4x is 4, so you have to write in the this denominator like this. Finally, So integration of sine square 2x is 1 by 2 x minus sine of 4x by 4 you'll get. So in the same manner, so integration of this cos square 2x dx also you can evaluate by taking the formula some cos square theta as it is 1 plus cos 2 theta by 2. Using this you can easily evaluate this one also. Okay. So these type of evaluation of single integrals are very important. Many concepts these integrals are arising here. So that's all. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.